Hello everyone, welcome to the brief presentation on the project Analysis of Image Quality in Video Denoising using Convolutional Neural Networks. Image processing has become a hot topic in the recent times due to the advances in technology. Computer vision, that is an allied domain to the image processing, has also grabbed the attention of the people. So what is image processing? It is nothing but the manipulation of pixels to produce various variants of the input image. There are different steps that are involved in image processing like image acquisition, image enhancement, image segmentation, and image restoration, etc. The concept of denoising can be seen under image restoration. So image restoration is nothing but producing an output image that is a replica of the input image. This is very crucial step in image processing where the output image is not corrupt by any external factors such as noise. Noise is nothing but some random fluctuation in the intensity of the pixel levels. So this can occur due to various factors like environmental factors or transmission channel interference, or noise can occur even while scanning the images. So we have to remove the noise to ensure that the image is perfectly restored as the original image. Hence, image denoising can be extended even to videos, which is called video denoising. And this is a very crucial challenge that needs to be addressed in image processing. This is a brief agenda of the project presentation. As said, denoising is a fundamental challenge in image processing as well as computer vision. Also, the sources of image and video noise can be environmental factors or channel interference, etc. Noises are of many types. The main types of noise can be Gaussian noise, Poisson noise, speckle noise, random noise, and salt and pepper noise. So, how do we determine the quality of the output image? Like visually, we can see two images and we can compare the clarity of the images and then we can say which image is better in clarity. But mathematically, we have some image performance metrics like PSNR, that stands for peak signal to noise ratio, mean squared error MSE, and structural similarity index SSIM. So here PSNR measures the signal power to the noise power, or the amount of original pixels present to the noise pixels present. And mean squared error measures the error between the reconstructed image and the original image. And SSIM measures the similarity between given two images. So the constraints that should be considered for getting a better reconstructed image are MSE should be closer to 0. This is in practical applications, but in ideal cases MSE is 0, which is not possible in real time. And PSNR should be as high as possible, and for denoising applications PSNR is desired to be between 25 to 30 dB. Lastly, SSIM should be closer to 1, which means that the two taken images resemble more to each other. The problem statement reads that to analyze the state-of-the-art deep learning techniques such as autoencoders, UNet, and some traditional methods like non-local means, median filtering, BM3D, that stands for block matching and 3D filtering, with any modifications for improvement in the performance metrics like PSNR, MSE, SSIM, and finally apply the best algorithm to denoise the video. Here I'd like to add that denoising is not a new research topic, but it has more scope for research. In the olden days, there were traditional techniques like spatial filtering and transform domain filtering. So in spatial filtering, we had linear and non-linear filters which had their own disadvantages. And transform domain filtering included wavelets, which are also under research. And currently, since deep learning has been finding so many applications, it is considered as the state of the art techniques even for image denoising, and we chose this topic in the project. The objectives of this project are to understand the concept of noise in images and videos, and the different noises are added to the images like Gaussian, salt and pepper, Poisson, and random. And the image dataset considered is FER 2013, that is facial emotion recognition dataset. The filtering techniques applied are NLM, median filtering, BM3D, and the performance metrics are calculated for each of these filtering techniques. Under deep learning, autoencoder and unit have been analyzed for comparative purposes. From the literature survey, autoencoder has been most widely used for the applications of denoising the images. Unit is a slight modification to autoencoder which yielded the better results. To apply the best algorithm, that is unit, with modified architecture and various filtering techniques to denoise frames and reconstruct the video. Here the modified architecture is nothing but that depends upon the input image size and all. Finally, preparing a technical report for the proposed work of DL-based video denoising. The basic methodology involves the implementation of autoencoder, but there is a disadvantage while implementing the autoencoder that there are some spatial features that might be lost when the pixels are moving or the pixels are getting downsampled from the encoder to the bottleneck and then upsampled from bottleneck to the decoder. So in order to rectify this problem, we put feed-forward connections as in the left side diagram, and to ignore the multiple turns here, we just modify the architecture into a U-shaped structure and we named it unit. So here the spatial features of the image are also preserved. This is the basic workflow of the autoencoder. We loaded the image dataset, and then image preprocessing includes resizing of the images and then defining the CNN model. We have defined 7 layers of the CNN. We set the loss function to MSE and optimizer as Adam. The model is fit with good number of epochs, and this is a very crucial step. We should ensure that the model is not overfit. And then the model is predicted on test data and the output is viewed, and finally calculated the image parameters. The proposed methodology involves the application of the same algorithm for videos. So a video is taken for testing, the noise is added to the video, and then the video is split into frames with some frame rate. This frame rate can be personalized based on our interest, and these frames are saved on the local computer. And then the same process continues as in for image denoising, such as image preprocessing, and then the modified architecture is defined based on the input video size given. These are the results and analysis. These two pictures show the results of autoencoder and unit on the FER 2013 dataset, where unit clearly outputs more clear images. These are the results of the conventional techniques applied. This is for NLM applied on 3 types of noises: Gaussian, salt and pepper, and Poisson, where it is proven that NLM works best for Gaussian noise. This is median filter applied for again 3 kinds of noises, where it is proven that median filter works the best for removing salt and pepper noise. Finally, this is the BM3D filter, which works the best for removing Poisson noise. In terms of tabular form, the PSNR and SSIM have been compared, and visually and also mathematically the results have matched. A graphical representation. These are the outputs of the 3 conventional techniques applied on the test video frames taken. And these are the outputs of the technique of modified unit applied on test video frames. This is the input noisy video, and this is the output denoised video. Here a point to be noted is that while training the model with good number of epochs, ensure that the GPU of the laptop is good and also the RAM speed is also good. So while training, it might take a lot of time if the laptop speed is so slow. Once the model is trained, we can save the model and we can apply the model to any raw video input given, which yields the best results. This is a tabular analysis where it is proven that unit works the best out of all the techniques considered. Also, SSIM also gives 0.965 for unit. A graphical analysis. To conclude, deep learning has proven to be more useful for image denoising when compared to the conventional denoising techniques. There are various DL algorithms that can be explored as part of the future scope of this project. Some techniques have been specially designed for denoising videos, which include the future scope, and also some common techniques for image denoising like CBDNet, ResNet can also be explored for removing noise from the videos as well. Thank you.